Hello, class. Welcome to week 7. So in lesson 7, we go over Microsoft Windows incident handling, security lifecycle, and best practices. Let's look at the module. And then next week is the only thing, and next week is the final. And so the overview, by the end of the week, you'll be able to describe threats to Microsoft Windows and applications, describe techniques for protecting Windows application software, perform incident handling and using appropriate methods, implement security controls to protect Microsoft Windows systems and networks, describe Microsoft Windows and application security best practices. And the key concepts include principles of Microsoft application security, procedures for securing Microsoft's client application server applications, Windows incident and Windows incident handling tools, the incident response plan, the system lifecycle phases, and these security lifecycle phases. We'll go over a little bit of SDLC and the security lifecycle, and also Agile software development, waterfall development, how it pertains to security. We'll look at Microsoft Windows operating system and application software security management, secure development, and revision and change management. We'll go over Microsoft Windows security best practices, and then finally looking at Microsoft Windows security management trends. And always, we may throw a little bit of Linux and other platforms out there like Microsoft Azure and AWS. No matter where, if we're in the cloud or where we're at, we're on Linux systems, Oracle systems, we should be performing the same procedures and doing baselines and checking for audit trails and doing incident handling. And so the learning materials, chapters 12 through 15. So 4 chapters this week, Microsoft Application Security, Microsoft Windows Incident Handling and Management, Microsoft Windows and Security Lifecycle, and then best practices for Microsoft Windows and Application Security. And so I'll bring up those. There's also the application security best practices and application security defense in depth, in which we've gone on over and over that we want to use the defense in depth, our layer defense posture. We want to try to catch any intrusions at the outermost layer, but we do want to do multiple layers because they will get through the first layer and maybe even the second or third. Then the discussion will be on security and the system development lifecycle and versus Agile. So how does it change based on our development methods? And then the labs, I believe there's 2 labs left. Yes, so the securing internet client and server applications on Windows systems, and then investigating security incidents within the Microsoft Windows environment. Everybody's been doing a great job labs, so just continue with the lab work and get those submitted. Those will be the last labs for the course. Let's see. And 12 through 15. So chapter 12 is on Microsoft application security, securing security strategies to Windows platforms and applications. The learning objectives are to describe the threats to Microsoft Windows and applications and describe techniques for protecting Windows application software. The key concepts include principles of Microsoft application security, procedures for securing Microsoft client applications, and procedures for securing the server applications. And so, of course, with the layered approach, we're going to want security at the client level, then also the server level, as well as on our network. It'll include application security, which covers all activities related to securing application software throughout its lifetime. And application software, any computer software that allows users to perform specific tasks. Examples, of course, commonly used email, browsing the web on our browsers, or creating documents in spreadsheet or Microsoft Office, or productivity tooling, including Slack and all the tools that we use to communicate and perform daily business. So the principles of Microsoft application security also include ensuring the software security includes security through the whole life cycle, including design, development, testing, deployment, maintenance, and retirement. And we want to protect our data. We want to make sure we're following the CI triad to make sure our data is protected. I did have a short video that we can watch.
Talking about information security, you may have come across the CIA triad. But what is the CIA triad and how is it applied to keep your business data and systems secure from threats? The CIA triad consists of 3 principles: confidentiality, integrity, and accessibility. These principles are considered the cornerstone of your organization's information security infrastructure, governing your business data and systems. Let's explore each of these principles in more detail. Confidentiality refers to keeping data private, ensuring data is not directly or indirectly disclosed or made available through any means of communication or observation unless absolutely necessary. This typically entails ensuring that only authorized individuals have access to specific assets and that unauthorized individuals are actively prevented from obtaining access. Confidentiality in information technology is achieved in several ways. These include data classification and labeling, strong access controls and authentication mechanisms, encryption of data in transit and storage, remote wipe capabilities, and adequate training for all individuals with access to data. Integrity involves maintaining the data's consistency, accuracy, and trustworthiness over its entire life cycle. Integrity ensures that data has not been manipulated or corrupted when being processed, when in transit, or when stored. Data integrity safeguards include encryption, hashing, digital signatures and certificates, intrusion detection systems, version control, and robust authentication procedures and access restrictions. Availability refers to the operational state of networks, systems, and applications. It enables authorized users to obtain resources in a timely and reliable manner when they are required. Regular software patching and system upgrades, disaster recovery plans, server network and application redundancy, backups, and fault-tolerant solutions are some of the countermeasures that help ensure availability. Anytime a security incident occurs, you can be sure that one or more of these principles has been violated. Depending on the security objectives of an organization, the nature of the business, its industry, and any regulatory requirements, one of these 3 principles may take precedence over the others. A crucial point to remember regarding the CIA triad is that favoring one or more principles may necessitate the sacrifice of others. This trade-off is not always negative, it is a calculated decision. Each business must decide how to implement these principles in light of their particular circumstances while maintaining the goal of providing a seamless and secure user experience. To learn more about cybersecurity for your business, follow the link below or subscribe to this YouTube channel. Thank you for watching.
Hi there, you're watching the IT Taster channel. I'm
Right. Yeah, that's the CIA triad. That's one of the important things about the CIA triad. As we increase availability, we have to worry, about meeting all 3 legs. So of course the users want their data to be the most available. But we want to make sure that it's secure and has integrity and is confidential where needed. So it's always a balance. One of the reasons why it keeps security at the forefront is ensuring that data is available but also secure and confidential and is accurate or has integrity. So if we look at some of the software attacks that are common, is malinformed input, and that's input that the application doesn't expect, and it can cause unexpected results. You'll see a lot of this, as we enter forms in the web is one of the most common ones. Our application developers should be checking and making sure that there is data requirements are that is formatted in such a way, like in a date format, they can only enter a date. If you're going to ask a age or a time, then they should not be able to enter a Java command through that input. Privilege escalation adds more authority to the current session than the process should possess. And so, again, we shouldn't be running processes as the root user, and definitely not having them automated as the root user or at elevated escalation. Denial service attacks can slow application and crash an application. And denial service attacks are more common than a lot of people think. I know, like I said, I've worked in e-commerce for quite a while, and we have DOS attacks almost daily. I can't remember the day we haven't had one, but we're using a web application firewall to detect these attacks and stop them before they impact the application. Identity spoofing, assuming another user's identity, is a common attack, and they can do this, not just with username and passwords, but with credit card numbers and other ways for users to identify themselves or to make purchases. Direct file or resource access. They can exploit holes in access controls. We discuss access controls, making sure that only users can access the resources that are needed. Extra application data access. They can access the application's data outside of the application, which we don't want. We want to most of the time we want to retain the data within the application. Application hardening process. Start out with a minimal install. Get rid of unneeded accounts and files. Use the principle of least privilege. Of course, we should always be patching our applications as well as our operating system, and then monitoring is huge. So install the application using only the option features that we plan to use. After installing the application, remove any default user accounts and sample data along with unneeded files and features. Configure the application according to the principle of least privilege. Ensure the application has all the latest available security patches applied. It's on a continual basis. And monitor the application performance to verify the application adheres to security policy. We do that through logging and performance evaluations. Some common Microsoft applications include Internet Explorer or Chrome, web browser. We also have Firefox, and of course there's others. Our email client, Outlook, is used quite extensively, but people also use Gmail, our productivity software such as Microsoft Office, our file transfer software protocol, and TCP/IP, and FTP, and App Logger, which includes software restriction policies and group policies. And we did go over some of that earlier in the course. Our web browser attacks include infect with malware, intercept communication, and harvest stored data. Like I said, Firefox, Chrome, Apple Safari are probably the three most popular web browsers, and it's how users mainly connect with the applications now across the internet, is through a web browser. It's become the standard way to build an interface into an application. So things we should be doing is set the internet zone security level to high, add trusted sites to the trusted site list as needed, configure a setting to prompt for first-party and third-party cookies, disable third-party browser extensions. We really watch those as you take in a browser extension. More and more browser extensions will be added. Enable show encoded addresses setting, and disable playing the sounds in web pages. And looking at some things you can do in the lab. Here's the Internet Options dialog box for IE level 11 and the trusted sites, and we can add a trusted site. And so you can do this at the organization level, and so for business partners and maybe our financial organizations that we communicate with, we can set them as trusted sites. Our email client, we should limit malicious code that may be attached to email messages, install anti-malware software on each computer, scan all incoming and outgoing messages for malware. And most people know now that, email and everything they do at work, is part of the organization owns the data. And so there's not an expectation of privacy as far as scanning messages for malware. Safeguard the message privacy by requiring use of secure socket layer and transport layer security, SSL and TLS, when connecting to the mail server. And so message exchanges are encrypted. And so just like in our other client server, we have email clients, which is usually Outlook, and then we also have Outlook server on the back end. Our productivity software, we should install anti-malware server that integrates with our productivity software. Use EFS and BitLocker, which we talked about earlier, to encrypt folder and drive that contains productivity software, documents, and databases. Never open files unless the source is trusted, and ensure productivity software has the latest security patches installed. Again, our productivity software, as far as Microsoft Windows goes, is Microsoft Word, Excel, Access, PowerPoint, Project, and Publisher. Of course, there's other productivity software like Microsoft Teams. You can use Slack. There's Windows has its own set of, or Apple has its own set of software as well. FTP is insecure, so we should be using FTP over SSL or secure FTP. And data transfers, we should really be running over a virtual private network or VPN. Our app blocker is a feature in Windows that allows you to restrict program execution using group policy. Provides the ability to whitelist applications as well. You can define path rules, hash rules, and publisher rules using group policy to restrict which applications a computer can run. And so, at work, we want to do this to lock down computers so only applications that are needed are being run. Securing our client applications, we should update software to the latest patch. Remove and disable unneeded features. Use the principle of least privilege, and use encrypted communication. Common server applications include our web server, our email server, and our database server. Almost every mid-sized organization is going to at least have these, including also print servers as well. The web server provides IIS, our Internet Information Services. The email server provides our Exchange, and our database server could be SQL, or it could be Oracle, or another version of a database. There's also our ERP software that provides unique user accounts, strong authentication, restricted access, and encrypted connections. And ERP, has been, if you have not taken the ERP class, is the goal to get rid of siloed systems and do enterprise resource planning across the entire organization. So there's a lot of data that needs to be secure in our ERP system. Then there's our line of business software, such as enterprise project management, workflow control, and service technician tracking and scheduling, or our ticketing system, depending on the organization and the industry you work. So securing Windows Server applications, we need to use server roles in Windows Server. Always update the software to the latest patch. Remove or disable unneeded services, and we discussed that last week. Filter network traffic and encrypt communication. And so again, we're looking at client server. So at the server level, we need to do the same things that we're doing and more on that we did on the client. So there is a roles wizard for adding a web server role to Windows Server. And so, you have Windows Server, then you're only going to have the server roles on that server active. And you can see that web servers are computers that share information over the internet, so it's going to add the protocols to be able to act as a web server. And then we select the role services on the Windows server, and then there's our common HTTP features, there's our logging, and there's our performance and security. And you'll see this in the lab as well. And our cloud-based software, like I said, Microsoft cloud-based projects such as Office 365 and Azure and OneDrive. Many issues related to securing applications are on the same as they are the same on premises, so they are on cloud. Remember, the cloud is still a computer, so we need to use the same security methods. We should review the options and settings and configure software to run the way it needs to be run, and harden the software, and don't just assume that it's secure because it is in the cloud. Still would have to verify who's making updates, who's making the patches, and who's monitoring for any changes. So best practices for securing Microsoft Windows applications include hardening the operating system, only installing the necessary services, using server roles when possible, and not using the server roles that are not needed on that server. Use SCT to adhere to Microsoft baseline guidelines. Remove or disable unneeded services. Remove or disable unneeded user accounts. Remove extra application components. Only open the minimum required ports at the firewall. Define unique user accounts and use strong authentication. So again, we want to have the machines only capable of doing what they're supposed to be doing. We want to use encrypted connections for all communication, encrypt files, folders, volumes that contain private data, develop a business continuity plan, a disaster recovery plan, disable any unneeded server features, ensure every computer has up-to-date anti-malware software and data, never open any content or files from untrusted sources, validate all input received at the server, audit failed logon and access attempts, conduct penetration tests to discover vulnerabilities. And so you can see that, as security analyst, there's quite a bit to do for Microsoft Windows application. This is true across any applications that we're going to monitor and maintain. So in summary, we went over the principles of Microsoft application security and procedures for securing the Microsoft client applications and procedures for securing the server applications. And so again, this is going to be over really any product that we support, Unix or Linux or AWS or Azure, but we're going to have to, have procedures to secure both the clients and the servers, whether they're on-prem, off-prem, in the cloud, no matter where they are. And it's going to be part of our defense in depth, our layered approach. So I think this would take us right to, that's 14. Chapter 13. Instant handling. So chapter 13 goes over Microsoft Windows incident handling and management. And again, these procedures and policies extend out to any platform that we're using and any applications we're using. And when there is an incident, it should be handled appropriately. So our learning objective is to perform incident handling by using appropriate methods. Only one learning objective. Key concepts include Windows incidents, Windows incident handling tools, acquiring and managing evidence, and then an IRP, incident response plan. So how do we find incidents? How do we handle them? How do we manage them? And then what do we do once we know there's one occurring? So the first, securing resources involves defining activities that are both appropriate and inappropriate. And so we need to know what an incident is. Is it going to violate security policy? or is it something that's expected? And then ensure we only allow appropriate activities. Any action that occurs within the computing environment is called an event, and any event that violates security policy or poses an imminent threat to security policy is called a security incident. And so events all happen all the time, and that's what we see in our logs. That's what we're logging. We're logging all the events. And so we're tracking any changes to the environment and all changes to the environment, and those are the events that occur. There's many types of security events, from minor to major incidents. An incident can be as simple as too many failed login attempts, or as complex as a coordinated attempt to compromise the database that contains confidential information. Some examples include excessive bandwidth used caused by compromise of a system, commercial use of IT resources, compromised computers, copyright infringement, digital harassment, IP spoofing, intruder activity, network attack or denial service condition, and virus or internet worm activity. You can see these can happen within or from outside our organization. And so we need to be tracking all the events that happen, the occurrences that happen on our computer and network, and then have policies in place, and then figure out if we're breaking those policies. And then even if policy is broken, it can be anywhere from minor to major impact to the organization. So handling Windows incident involves Microsoft Windows OS and applications. Examples of incidents include virus or internet worm activity, IP spoofing or internet protocol spoofing, intruder activity, network attack or denial service condition. And the first step in responding to an incident is recognize that an incident has occurred. This is, very scary. You can find on the news all the time about data breaches. The most notable one is Target a few years ago, and it was months before they even knew that someone was inside the database pulling confidential information. And so determining that there is an incident is the first step. To minimize the number and impact of incidents, we should develop, maintain, and enforce a clear security policy that management supports and promotes. And so we want to have a support from our management, on the policies. In fact, really the management should be the people that approve the policies, and then security should be the people that enforce the policy. We should conduct routine vulnerability assessments to discover vulnerabilities that can lead to incidents. Also, to minimize the number and impact of incidents, we should ensure all computers, network devices have the latest available patches installed, and that's at the application level, the network level, and the OS level. Train all computer system users on acceptable and unacceptable behavior. Again, going back to, if somebody tries to log into a machine they're not supposed to be logged into, they may not know that's unacceptable behavior. And then establish frequent and visible security awareness reminders. It's very common for people to open up attachments to emails without thinking about the security implications. We should enforce strong passwords throughout our environment and frequently monitor network traffic, system performance, and all available log files to identify incidents and unusual events. So our log files should be logging, but they also, if you look through Unix log files, there'll be normal, error, instant, right in the messages that we can monitor for. We should ensure we have a solid business continuity plan and disaster recovery plan and test it at least annually. They say annually, but we should be reviewing those DRPs and PCPs frequently, and create a computer security incident response team. So who is going to do what when we have an issue? And we should be walking our information system and checking every component and what happens if we have, a router go down, if we have our network go down, if we have the database go down. How are we going to respond? And that includes assets in the cloud as well. So formulating an incident response plan, we need to plan, create a computer security incident response team, or CSIRT, plan for communication, plan for security, test the plan, and revise procedures. So all our plans, as always, should have a test. We should be testing them to make sure they work and they're appropriate. Handling incident response. We want to look at our preparation, identification, containment, lesson eradication, recovery, and then lessons learned. So we always want to be preparing for the latest incidents that are out there, identifying any incidents that occur, containing those incidents as soon as possible, eradicating those incidents, recovering from the incident. It could be restoring data, for example, and then doing lessons learned, which is almost part of preparation. So looking at the incident reporting form, this may be one of the ways that we find an incident outside, but we general information like the name, the title, the date, time it was detected, how do we get in touch with the user, the type of incident. You can see here's some like the unauthorized access, unauthorized use, hardware, software failure, failed access attempt, malware, infrastructure failure, a denial of service or scan, and then there's others as well. And then how was the incident detected, and then any additional information. So all evidence you present in a court of law must exist in the same condition as it did when you collected it. Evidence cannot change it once you collect it, and it must be in pristine condition. And so this does have legal implications if an outside entity is attacking our information system. You'll be required to prove in court that the evidence did not change during investigations, and provide your own evidence that all collected evidence exists without changes as it did when it was collected. The document that provides details for every move and access of evidence is called the chain of custody, and the chain starts when you collect any piece of evidence. Since you don't know if you'll have to present evidence in court, you should collect all evidence during an incident investigation as if you would take it to court. Carefully preserve the chain of custody, and do not go to court. You have well-documented evidence. The information is great for analyzing incidents, for lessons learned, step of the incident response. And then any carelessness can, have severe implications in court. And always treat investigations as you'll end up in court. So handling evidence is extremely important. Because like I said, working for mid-sized, even large companies, we can be request to go to court. Here's the 6 phases of incident response provided by Infogress Cybersecurity Solved. So I wanted to show this kind of as an overview of them going through the incident response.
So you've just seen something strange. Perhaps the logs on your VPN server show a user who's sitting right next to you has also just logged in from Hong Kong. Or someone on your customer service team notes that they can see an accounting file that no one should have access to. Something strange has definitely happened. Is that strange thing a cyber incident? How do you decide, and what do you need to do in case you decide that it is? Just about anything, from discovering malware to identifying suspicious user activity, could be legally defined as a cyber incident under HIPAA security regulations. So how do you know when it's time to implement a full incident response plan? The correct answer is that it's always time to implement your incident response plan. Let's go over the key elements of an incident response plan and important things to consider when you think you may have been the target of a cyber attack. Incident response is typically broken down into 6 phases: preparation, identification, containment, eradication, recovery, and lessons learned. Most organizations mainly focus on containment, eradication, and recovery, and completely skip lessons learned. But the truth is, this last phase is potentially one of the most important. Preparation. Preparation is as straightforward as making sure you have a trained incident response team, either employed, on retainer, or at least someone's business card so you know who to call. Identification. An incident is initially identified in any number of ways, leading you to start your response plan with only slight awareness of what the incident may be. The identification phase is meant to clear this part up. This phase also includes the investigation of the depth of the compromise, its source, and its success or failure. Identification is done through review of log files. Lots and lots, and sometimes lots and lots and lots of log files. The important consideration at this point is not to disrupt any potential evidence of the incident. A well-trained and equipped response team will be able to rapidly parse log files, review forensic images, and do so without damaging any evidence in the process. Containment. Containment often happens concurrently with identification or immediately following. Damaged systems are removed from production, devices are isolated, compromised accounts are locked down. The bleeding stops here. Eradication. Eradication is exactly what it sounds like: removing and remediating any damage discovered in the identification phase. This is normally done by restoring systems from backup and re-imaging workstation systems. It's important to note that proper eradication of a cyber infection should be done by trained professionals and should only be done after comprehensive investigation to the incident is completed. Time and time again, small organizations will be quick to delete, restore, and re-image after the first sign of an incident, before they've learned how the attacker got in or how much damage was really done. In many cases, when systems are reset so quickly, the organization has no way of going back to learn what happened and, as a result, are often hit by the same type of attack again and again. Recovery. Recovery is the testing of the fixes in the eradication phase, and the transition back to normal operations. Vulnerabilities are remediated, compromised accounts have passwords changed or removed altogether, and replaced with more secure methods of access. Functionality is tested, and day-to-day business resumes. Lessons learned. The last phase is one that many organizations skip, but it's arguably the most important to prevent future incidents. Lessons learned involve reviewing the steps that were taken during each phase and improving both your incident response capability and your security footprint. If you rush to get back up and running but never stop to consider the implications of what caused the security incident, you may never improve your cybersecurity standing. Whether it was human error, security holes, or a flaw in a security product, your organization should review what went wrong and use the incident as a stepping stone to work towards a solution. Without this stage, you may find yourself running back through these steps again and again with every subsequent preventable incident. What now? Incident responses are best performed by persons trained and equipped for it, with proven processes and full support from leadership within the business. In addition, with the advent of cyber insurance, it's becoming more and more common for a full response to be required before settlement can be made. If you have any questions about cyber incident response, or suspect you may be compromised, contact Infogressive today. We're here to help.
All right. Let's see. Chapter 13. So that's just a to review the instant response cycle. So looking at incident handling and management tools, there's two basic types tools that help manage the CSERT's activities and gather information about the incident response process, and tools that collect information about the incident itself. CSERT responsibilities, that is the Computer Security Incident Response Team. They should track incidents, report on incidents, archive incident reports, and communicate incident information. So any incidents that happen, what do we do about them? What are we doing about them? And the CSERT team will take that. They'll collect technical information to support incident investigation and resolution, collect evidence on incident activity to discover what happened, why it happened, how to stop it from happening again. Discover traces on past activity in memory, stored on disk or in log files. Find evidence of incident activity. So questions asked during the investigation: what happened? Who did it? When did it happen? Where did the incident originate? Where did it target? Why did the attacker attack the system? And how did it happen? We should treat investigation as it end up in court. Like I said, investigation should produce evidence of the incident and possibly support action against the attacker. Evidence can be in kind of any form. It can be pictures, executable files, log files, statements. Most common type of evidence is real evidence or physical object, and documentary evidence, written evidence, or file contents. And it is required to prove an accusation. Chain of custody: all evidence you put in court must be the same as when we collected it. Cannot change at all. Once you collect it, must be in pristine condition. And the chain, like I said, starts as soon as the incident occurs. And then we have to document any changes or handling of the information or any updates to the chain of custody. Here's the sample chain of custody log. You can see the item for this case. It's a hard drive. The data was collected, that it was seized, that it was transported, that it was removed, and then returned to the locker. Evidence collection rules: each state and local jurisdiction may impose slightly different rules. We should know our federal, state, and local laws and policies. Different rules govern different types of evidence. Contact local law enforcement, learn how they approach investigations. Contact your organization's legal representatives, bring with a CSERT legal team representative. So looking at some best practices for handling incidents, we should harden our OS and software to avoid incidents. That includes OS and application software. Assess computers periodically to expose vulnerabilities. Validate our business continuity plan and disaster recovery plan. So it's not enough just to create the plans, we should be testing them. Get full management support for a CSERT. Create the CSERT, of course. Conduct a risk assessment to identify potential incidents that require attention. Develop an incident response plan around the 6 steps to handling incidents. Create an incident reporting form or procedures. So users should, if they report an incident, they should know what information they need to report, who they report it to, when they report it. Distribute and publicize the incident reporting form or procedures. Test the incident response plan before attackers do. That's very important. Identify and acquire incident management software. Identify and acquire incident investigation software. So obviously, just like our ticketing systems, we can have an incident management and ticketing system, where users can report incidents online, where they can be automatically reported from log files, and then we can manage those incidents in this incident management software as well. And then train key CSERT members on proper evidence collection and handling. So, in summary, we went over Windows incidents, and of course, this applies to incidents across anywhere on our platform, including all applications, Linux, in the cloud or on-prem. We looked at incident handling tools. We looked at acquiring and managing evidence, and we looked at our incident response plan. That should be, again, one of the plans that we are testing and updating frequently. So let's see, moving on to Chapter 14, the Microsoft Windows and Security Lifecycle. So we have a software development lifecycle, which can be with the waterfall method, or traditional, or it can be agile. We also need to have a security lifecycle. So our learning objectives is to implement security controls to protect Microsoft Windows systems and networks, and describe techniques for protecting Microsoft Windows application software. Some of the key concepts include system lifecycle phases, agile software development, Microsoft Windows operating system and application software security management, software secure development, and application software revisions and change management. And again, these concepts go beyond just Windows and go to all platforms. We need to understand the software development cycle, which is considered the more traditional formal model, usually seen in 6 steps or 7 steps. Also referred sometimes to waterfall, to a more iterative sprint-based agile development approach. Usually with the SDLC, we're looking at maybe one release a month or once a quarter, where the agile, we can have releases every other week or every third week or sometimes every week. And, we're pushing code out much faster, or changes much faster. So the SDLC is commonly implemented as a waterfall approach in the past, breaks down software development process into a number of phases with the goal of standardizing or simplifying software development management with specific start and end dates with deliverables. And the author here shows it in 10 phases. Sometimes these phases, like initiating, like planning, modeling will be together, the requirements analysis will be together, and coding testing will be together, and maintenance and disposition may be together as well. And it can be shown as a circle as well, but the author shows it here as initialization, modeling, planning, the requirements phase, the analysis phase, coding phase, testing phase, implementation, maintenance, and deposition. And the author in our case is only showing the SDLC, then the agile method. But of course, there's many other methods out there. We could do rapid application development, kind of condense this down, these down. We can do joint application development. So there's, more than just these two. And most organizations don't pick one or the other. It doesn't really make sense to put an application that only needs changes 3 times a year into an agile development cycle. But if we are doing more rapid changes, we may move to agile software development based on small project iterations or sprints instead of long project schedules, and produces smaller deliverables frequently. And they show it as a mixer with the where it's continuous cycle of demo or sprint planning, requirements, analysis, design, implementation, testing, and demo and evaluation. So we have our initial planning and then our deployment, and this is happening all the time, where we're trying to decide what we need to work on, what can we get into the next release, and then pushing those out the door. Looking at the OS and application software security, create one project to develop complete application software. Create a new project for each individual program, create a project for a group of related software programs, and use the agile method for each project. Here's our Microsoft Security Development Lifecycle, or the SDL. You can see that we have training. And again, you can show this as a circle versus a straight line. Our core security training, we need to develop our requirements, which includes our security requirements, our bug bars or quality gates, our security and privacy risk assessment, look at our design, which is establishing our design requirements, analyze our attack surface, look at threat modeling, moving into implementation, use approved tools, depreciate unsafe functions, or remove them, static analysis, getting in verification, look at dynamic analysis, fuzz testing, attack surface review, and then during the release, look at our IRP, our incident response plan, do a final security review, look at our release archives, and a response to execute our incident response plan. And it have a video on the Microsoft security development, I believe from Microsoft.
Hi, I'm Patrick from Microsoft. As a company-wide initiative and mandatory security policy since 2004, the Security Development Lifecycle, or SDL, has played a critical role in embedding security and privacy in software and culture at Microsoft. Combining a holistic and practical approach, the SDL aims to reduce the number and severity of vulnerabilities in Microsoft Online services. It does this by embedding comprehensive security requirements, technology-specific tooling, and mandatory processes into the development and release lifecycle. It is developed by security subject matter experts and in accordance with industry best practices and regulatory standards for compliance. All Microsoft Online services must follow Microsoft's secure development and operational security requirements. While SDL tools run automatically as part of the build to detect security issues within the code, operational security requirements help maintain security best practices. In addition, engineers participate in a wide variety of training to help build security awareness and knowledge. This video will walk you through the core principles of the security development lifecycle and operational security processes at Microsoft. To ensure that Microsoft engineers cultivate a defensive mindset and have an awareness of emerging threats, all employees are required to take basic security awareness training, both as part of their initial onboarding as well as annually in order to maintain access to production systems. In addition, all members of software development teams have access to advanced security and privacy training. This includes personnel who are full-time employees, interns, contingent staff, subcontractors, and even third parties. As the implementation of new features are planned, threat models are created or updated to represent the new data flows between components specific to these functional scenarios. The associated data flow diagrams allow for a study of an application's security and privacy risks by outlining primary functional flows and capturing details such as data flows between components, sequence of interactions and protocols used, and sensitive data handling and storage. Microsoft integrates mandatory security tooling at different phases of the engineering process. These phases are generalized as development, check-in, build, and post-release operations. So what are these different types of tooling? First, static code analysis tooling is used to analyze source code and identify patterns that could have a potential security impact. Next, there's binary analysis tooling. It is used to assess threats and vulnerabilities at the binary code level and confirm that each build is production ready. Credential and secret scanners are used to identify possible instances of credentials and secret disclosures in source code and configuration files. Encryption scanning tooling is used to validate encryption best practices, both in code and operation. Endpoint scanners are used to scan endpoints for known vulnerabilities and misconfigurations. There's also fuzz testing tooling, which uses malformed and unexpected data to exercise APIs and parsers, looking for vulnerabilities and failures, as well as validating proper error handling. And finally, configuration validation tooling analyzes the configuration of production systems against security standards and best practices. Penetration testing of Microsoft Online services occurs periodically and is conducted by both internal teams and external providers. We also have a bug bounty program that invites researchers to submit possible security findings that they have discovered. The use of open source software is strongly encouraged at Microsoft. building on the efforts of others allows us to create a meaningful value for our customers faster and engage with new ecosystems and user bases in a natural way. However, Microsoft also understands that there are unique risks and responsibilities associated with using open source. The Microsoft Open Source Programs Office, in cross-company collaboration with legal, security, and business stakeholders, have put together a comprehensive suite of policies, processes, and tools to help our developers work with open source in a secure fashion. On at least a yearly cadence, through third-party audits, Microsoft Online Services demonstrate that these security requirements are being met. Microsoft is continuously investing in its people, security awareness programs, and best-of-breed tooling to focus on measuring and alerting of known risks. Thank you for watching. Additional papers and external audit reports can be found on the Service Trust portal.
So there is a Microsoft Service Trust portal as well that you can check out, and you may use in the industry. So when you look at building security, the maturity model is the framework developed by a consortium of organizations to help design a development process. It defines 116 unique activities along with frequency. There's also the software security framework, which is a framework of 116 activities that groups 12 practices into 4 domains. The SSF includes governance, intelligence, SSDL touchpoints, and deployment. Look at strategy and metrics, compliance and policy and training. Look at attack models, security features and designs, standards and requirements, architectural analysis, code review and security testing, deployment, as we see in the video, penetration testing or pen testing, software environment, and configuration management, vulnerability management. The process of developing secure softwares includes providing training in secure development, includes security from the beginning, use security programming techniques, and test for vulnerability. So we should be having secure development throughout this SDLC or throughout the Agile development lifecycle. Common pitfalls for code include a lack of input validation. We discussed this earlier, but through our forums, and this should be done at every level, but especially at the code level. Information leakage through poor error handling, sloppy authentication or encryption, remote system access or code execution, and dynamic code execution. So we want to make sure the developers are aware, that security should be integral to everything they do, that they cannot rely just on, the user authenticating into the network. Implementing, evaluating, testing Windows OS and application software security. The purpose of formal testing is to evaluate how well the application meets overall performance, functionality, and security goals. Every goal from the original specification should have at least one corresponding testing scenario. The testing scenario evaluates whether the application satisfies the goal, and testing activities can be manual or automated. Possible problems of faulty code include inconsistent code or schema changes, inconsistent interfaces with other programs, and faulty installation procedures. We need to keep development environment and tools up to date, just like our OS and our applications. Ensure the OS has software development computers with the latest security patches. Adjust the vulnerabilities discovered in the application software as quickly as possible. So we should identify as early as possible and then, of course, address them. Document the changes and have a plan to reconcile production changes with testing as soon as possible. Check that all maintenance procedures protect the data security. Looking at the Windows OS and application software revision and change management. Software development areas difficulty include face identification, phase transition, and activity coordination. Software control includes our baseline identification, change control, communication, and implementing repeatable processes. Our SCM is our configuration identification, our configuration control, auditing, and status accounting. So some best practices include to incorporate security early and often or throughout the whole life cycle. Adopt a software development model to help define the organization development activities and flow. And like I said, we may not use the same SD software development model for every application, especially in a large organization. Define activities for each phase of your model. Ensure all developers are trained to develop secure applications. Validate the software product at the end of every phase. And we should create separate software projects for each related group of programs or program changes. And do not begin a software development project by writing code. Should be planning and designing first. Keep the 3 SDL core concepts in focus: education, continuous improvement, and accountability. Develop tests to ensure each component of your application meets security requirements. Study the most common application vulnerabilities and develop programming standards to ensure we don't include vulnerabilities in the application. Identify and store programs, files, and schema definitions in a centralized secure repository. Control and audit changes to programs, files, and schema definitions. Organize version programs, files, and schema definitions into version components. That way we can always back to a previous version. Organize version components and subsystems in their version subsystems. Of course, create baselines and project milestones. Record and track all requests for change. Organize and integrate consistent sets of versions using activities. And maintain stable and consistent workspaces. And finally, ensure reproducibility of software builds. And so we shouldn't be doing builds where we cannot return to a previous version. So in summary, we talked about the systems lifecycle phases and agile software development, more, waterfall versus agile, but realize there is more than just those two. We look at Microsoft Windows, the operating system, application software security management, the application software security development, and software revision and change management. So throughout the development lifecycle and throughout the application lifecycle, we want to go through the whole life cycle. Oops. So chapter 15. Last chapter for this week. I know 4 chapters this week, so it's quite a bit of information. But the last chapter, there's only one learning objective, which is to describe Microsoft Windows and application security best practices, which we've been going over best practices at the end of each chapter. Key concepts include Microsoft Windows security best practices and security management trends. And again, these best practices, we should be, looking at the best practice code on all our platforms and applications. So administratively, we need to develop and maintain policies and implement each in the best practices session. Educate users, establish incident response capabilities, ensure we know the business functions are critical. We want to identify the critical business functions and then develop a business continuity plan on how to make sure those functions will be available for any incident. Define recovery time objectives. So if something does go down, how long can it be down? And that'll help us develop a backup plan. Document backup and recovery procedures and test all recovery procedures. And again, this can be different it's going to be different based on our industry and organization. If you look at an insurance, I'll use USA as an example. Out in San Antonio, they have 2 different electrical companies providing electricity to their facility, and they also have battery backups in the basement. But they want to be available in case of a natural disaster, that type of incident. And so, that's part of their plan is, determining what needs to be available and then making plans to make sure it's available. We want to review and regularly update our plan update old password policies, never write down passwords, encrypt folders, not files, designate recovery agent accounts, avoid using principal files, require strong passwords, use a CA or certificate authority or trusted sites. And for most assets, we want to require two-factor authentication that we went over in the discussion questions. Technically, we want to install anti-malware software, enable real-time scanning, update signature databases and software daily, perform a complete scan, usually weekly, quick scan after installing any new software, and enable boot time virus checking. We want to remove administrator rights from all normal users, apply software and OS security patches, block outbound network connections, automate our backup operations, and verify our backups. Any backup plan and procedures should be verified. Export encryption recovery keys to removable media. Encrypt the My Documents folder. Use multi-factor authentication or at least two-factor authentication. Store recovery information in BitLocker. Disable standby mode for portable computers that use BitLocker. When BitLocker has been compromised, remove the BitLocker metadata. Use strong encryption on VPNs. Use STP for VPNs when possible. And disable SSID broadcasting for wireless networks. Of course, never use the web for wireless networks. We want to use WPA 2 or 3. Our audit and remediation cycle. So this is a complete cycle where we plan, which is establish objectives and processes to meet a stated goal. In the context of routine auditing, the goal should be to assess specific security controls. And then do, which is to implement the process we planned in the previous step. Then to check, measure the effectiveness of the new process and compare the results against the expected results for the plan. And we'll do that by auditing our baseline. And then act, analyze the differences of the expected results and measure results. Determine the causes of the difference, and then develop a plan to improve the performance. So again, you can see this is continuous cycle. Plan, do, act, check, act, and then plan again, and just a continuous cycle. We want to maintain current backups of all audit information. Don't enable read and list auditing of any object unless we need to. Don't enable execute auditing in binary files. Limit enabling of all audit actions to files, folders, programs, and certain other resources. Enable auditing for all change actions for your Windows install files, any folders you use on normal business operations. Audit printer actions. Ignore rewrite actions for temporary folders, but audit change permissions, write attributes, and write extended attribute actions. Develop Windows policies and GPOs that are simple as possible and still satisfy your security policy. This is a real bear, or can be real bears. You know, our GPOs getting kind of out of control and having overlapping security policy or Windows policies. Develop clear guidelines to evaluate each element of our security policy. Know what we'll be looking for before we search through the audit logs, and a lot of audit logging can be automated. Our group policy is an important component of securing the Windows environment. Helps centralize the settings to ensure conformance with security policy. And we should develop comprehensive group policy, use it to apply settings, ensure settings are correct. So our OU should reflect the organization's functional structure, and then create the GPOs for required in your security policy. Use meaningful names. Deploy the GPOs in a test environment before production. Use security filtering and Windows management instrumentation filters. Backup our GPOs regularly. Do not modify the default policies, instead create new ones. Use the reference spreadsheets for more information on GPO settings, and you can find those at Microsoft. Acquire Windows Server security compliance management resources that help design, deploy, and monitor the server baselines. use security compliance management resources to design, deploy, and monitor the workstation baselines, and use the local policy tool to automate deploy recommendations of the security compliance management toolkits. So looking at the security baseline analysis is valuable for showing known values and valuable for showing compliance. We need to create our initial baselines, use tools such as security configuration analysis and the Microsoft Baseline Security Analyzer, which we did labs on those. We had discussions on those before. And we can schedule our scans using baselines. So we need to create the initial baselines that represent the secure starting point. Then do the templates and change templates as needed, and run the SCA Microsoft Security Analyzer, which is command line interface. And then, like I said, develop the batch files to do it automatically. Got one short video on that. Very short, less 2 minutes.
Hi all, today we are going to see what is security baseline. Once an organization has identified and classified its data, it will typically want to secure them. That's where security baseline comes in. Baseline provides a starting point. It ensures a minimum security standard. One common baseline that organization uses imaging. What is imaging? Administrator configure a single system with desired setting, capture it as an image, and then deploy the image to all other systems. This ensures that systems are deployed in a similar secure state, which helps them to protect the data. Even NIST SP 853B, Control Baseline for Information System and Organization, has presented 4 types of baseline: low impact baseline, moderate impact, high impact, privacy control, based on the potential impact to the organization. So once we identify the potential impact based on the confidentiality, integrity, and availability of your system, then we can apply these controls. Once organization select a control, they have to fine tune it with tailoring and scoping process. What is tailoring? Tailoring refers to modifying the list of security controls within a baseline to align with the organization mission. What is scoping? Scoping is part of tailoring process, but it refers to reviewing a list of baseline security controls and selecting only those that apply to the IT system that you are trying to protect it. Thank you for watching my video. Make sure to subscribe, like, and don't forget.
All right, great. There's a few more slides. So the OS application check subkey, we should deploy security controls, harden our operating system, harden our applications, and again, it's just an ongoing cycle where we want to do all 3. Network management tools and policies, identify and protect sensitive data, establish unique domain user accounts, enforce strong passwords, limit rights and permissions for services, don't allow services run under the admin user, use Kerberos, install firewalls to create a DMZ, encrypt our files and data, establish firewall rules. We only have ports open that are needed. Use anti-malware software. Use the WPA for wireless networks to disable our SSID. Disable WPS. Don't enable wireless or broadband cards that we are not needed. Don't allow visitors to roam the facilities using the wireless LAN. Avoid connecting to Wi-Fi public networks. We should have separate access points for guests, and disable or remove services not needed. So again, I'm looking at software testing, staging, deployment, adopt, define, ensure, validate, and create. So don't begin the project by writing code, planning, and design it first. Keep the SDLC core concepts of focus, education, continuous improvement, accountability, develop tests to ensure our components meet security requirements. Study the most common application vulnerabilities, develop standards to ensure they're protected. Identify and store programs, files, and schema definitions in a secure, centralized repository. Control and audit changes to program files, programs, and schema definitions. Organize our version programs, files, and schemas and version components, and put them in version collections. Create baselines of project milestones. Record and track all changes or change requests. Organize and integrate consistent sets of versions using activities. Maintain stable and consistent workspaces and ensure reproducibility of software builds. Again, as we're doing builds, we should be able to, return to them. To maintain secure access for remote clients, check a list of best practices, including mapping the proposed remote access architecture. Use one of the several available network mapping software products to make it easier, and then update that map as we make physical changes to the network. Have firewalls installed, VPN endpoints. Select a good VPN provider and solution. Use a global user account whenever possible. Create a limited number of administrative chat accounts and make sure their permissions are modified and things are not running and as admin user is not needed. Develop a backup recovery plan and test the plan. Implement frequent update procedures for all OS application network devices. Monitor the VPN traffic for performance and suspicious content. Carefully control any configuration changes and physical changes to main nodes. Require encryption for all communication and remote access to main. And enforce anti-malware minimum standards for all remote computers as well as server computers and the remote access domain. So looking at some trends, more often than not, social engineering has been more and more on the rise, as hackers attempt to get access to information networks. Mobile devices uses bots. It's very easy to create, script kiddies and bots to try to attack a system, and scams by questionable security consulting or software firms. Data focused attacks, more often than not, our attacks are really just trying to access our proprietary or personal information. And we're using more cloud computing, but we still have the same security requirements for our assets in the cloud, and the malware continues to expand. So in summary, we looked at Microsoft Windows security best practices and Microsoft Windows security management trends. So we enjoyed this week 7. Like I said, get the assignments done for week 7. Got a couple labs this week, and 3 assignments in our discussion on security in the SDLC versus Agile. And if you want to throw in there, the other different development cycles, would be great. I hope you all had a good week and enjoyed the course so far. We're almost there, and I thank you for your time.